Alright, so this is the robot that barely got us to state. I'll start with the lift. So one motor for a linear actuator, whatever you call this. Basically just lifts the ramp up and down. We got a limit sensor right here. So in autonomous, when it hits that point, the lift motor knows to stop, so the whole ramp stops. And then there's one more lift sensor right there. Same thing when the ramp is in, like, all the way down here, it knows to stop. So there weren't really any problems with the linear thing at all. Worked fine. So now here's the intake. This went through a couple changes, and went through a couple changes. So this big flex wheel, well, not big, I guess like the medium one or whatever, second largest one, is directly connected to the motor. Nope, I'm wrong. This is, so I forget what kind of ratio this is, but motor runs, the smaller gear, which in turn turns the big gear, which gives us torque, and straight from this gear it runs to this wheel, because this wheel needs quite a bit of torque to get the disc up from here, from the bottom up. And then there's another gear, big gear to small gear for speed, and it's the same ratio for the other side. So the reason this was geared for fast intake was because we wanted to get the disc in our robot really fast, but then it would be getting stuck here a little bit when this was also geared for high speed. So instead we came up with the two different ratios on one axle or whatever, and yeah, sucks it up fast, gets through here, and then the rest of the conveyor and whatnot is also fast. And this second smallest flex wheel is here to help push the disc up. And this roller I'm really not happy with and barely works, is connected into the intake. And since we made it to state, I'm gonna, I won't completely scrap, but I guess I will scrap it, because I'm gonna completely get rid of this whole intake system because it's really bad, really slow, which I'll show towards the end of the video. But yeah, it's really slow and not that great, so I'm gonna be changing that. The drive is just simple 4-motor drive, don't know the ratio but torque, and it's a blue motors for torque. This lift motor is red. Probably doesn't have to be red. But now for the flywheel, so we have two green motors. Two green motors spin the small gear, which is on the same axle as this big gear, and then this big gear is geared for speed. So this is for torque, this is for speed, which in turn gives us a really fast flywheel. And this allows us to shoot across the field and score us points in Auton and in skills, which is what we wanted. That was our goal. We used to have just two motors running to this gear, and then the flywheel was on this gear, which didn't give us a lot of range, or not as much as we wanted. And then because we have no pneumatics, because somebody stole our pneumatics some years ago before I joined, or most of my team joined, we're stuck with just 8 motors. So we got 4 on the drive, 1 for the lift, which is 5, 6, 7, and then 8. So we were still left with endgame. So what I decided to do was to connect the endgame to the flywheel. So the way flywheel was activated is by the flywheel spinning in reverse. So our button to spin the flywheel in reverse was up arrow, and that was for endgame. And normally it's R1 to shoot the discs, but how this works is this is a crown gear, so horizontal to like vertical or whatever. Then there's a sprocket here, small sprocket here for a bigger sprocket there. I think that gives it more power, more torque. And then this is on another axle. And this is a ratchet. So how this works is that this flywheel, this crown gear is always spinning, but this is a ratchet, so it only activates when flywheel swings in reverse. So this ratchet has a string on it, and this string pulls this gear downwards. And what's up here is the locking mechanism, which I'll lock in a second. So it locks like this. There is a hole, well, it's a U. There's a U on this, bro. Let me just show you. So up arrow, this gear gets pulled forward, which turns these screws that are in a collar forward, therefore unlocking the end game, throwing the end game. So up arrow, and they fire. So as I was saying, there's like a U cut out right here, and the screws, the screws slot into that U. And this is a pretty good locking mechanism. It was never activated by accident, so it's good. One of our problems was that we came to the competition with endgame that was with string on our endgame that was less than 3 millimeters, and I didn't know this, but I guess there was a minimum diameter requirement for the strings. So that kind of threw us off because we had to go to Menards, get some 3.5 millimeter paracord. I think it was 3.5. I'm not sure anymore. But this paracord worked okay, not as well as our, like 2.8 millimeter or 2 millimeter string that we had before. And that other string used to just slot straight into here. And the nuts we had earlier were also illegal, I guess, even though there were other teams using our nuts. But what we decided to go with was a zip tie with collars on it, and it was pretty much the same weight. It slides on the same way, so it worked okay. But we used to get like 9 to 12 tiles with our old end game, and we were getting like around 7 with this one, so kind of brought us down. So this was also makeshift. This was made in like 30 minutes, like when we first got there. And yeah, so the most interesting aspects of this to me are how we created the end game and the lift. We tried to be a little innovative. This is what I decided. So yeah, what I'm planning to do is strip this whole intake down, completely make a new remake the roller because our roller is really unreliable. It was barely spinning the rollers. It took way too much time. Intake is okay, but it needs to be a lot better if we want to make it past state. So I need to improve the intake a lot, roller a lot. Our shooting is pretty good. It's just the intake needs to be a lot faster if we want to shoot the discs out much faster. So yeah, the programming was really good, but I think I can't do it. So proud of those guys. Auton did pretty well most of the time. Our skills programming wasn't that the best, like 45 points, but stuff was weird. But yeah, that's it.